Hello, my name is Josh, and today I'm going to be explaining the wave equation and some of its properties. First off, some key terms are needed to understand the equation more thoroughly. Two of the main terms we need to know are wavelength and frequency. These will be plugged directly into the wave equation. A wavelength is the distance that a wave travels. The unit for wavelength is normally meters, but can be centimeters and so on. So to find wavelength, you would have to measure the crest to crest or trough to trough. Frequency is the number of wave cycles divided by time. Frequency is measured with a unit called hertz. On a side note, wave speed is also part of the wave equation, and it will be what we are solving for. Wave speed is how fast the wave is traveling and is measured in meters per second. Some extra terms that don't show up in the equation are medium and period. A medium is the material a wave travels on. A period is the time it takes for one wave cycle to travel. It should also be noted that frequency and period are opposite reciprocals. Now to get the equation, we can use the speed formula as a template. So if speed equals distance over time, speed would then equal wavelength over period. However, period can be replaced with 1 over f, and we can change it so we can have wavelength over frequency. Wavelength would be the distance and frequency the time. After some rearranging, you are able to find the complete wave equation. V equals frequency times lambda. The V represents the wave speed in meters per second. Lambda, the upside down looking Y, represents the wavelength, and finally the F represents the frequency of a wave. These three components, frequency, wavelength, and speed, make up the wave equation. For this screencast, I'll be using the wave equation to find the speed of a wave that have equal mediums. However, it should be noted that the wave equation can be used to find all three of its components. To find wavelength, you would take the speed and divide it by the wave's frequency. To find frequency, you would take the speed and divide it by its wavelength. If a problem doesn't give you frequency or wavelength, it can be easily found, but for understanding the equation, they will be given. The wavelength in the first problem is 1.75 meters, and the frequency is 2.0 hertz. You would then take these two numbers and plug them into the equation, V equals lambda times frequency, then multiply them together to get a speed which is 3.5 meters per second. You would do the same for the next problem. Multiply the frequency and the wavelength to get 3.5 meters per second again. The next two problems will both multiply to be 2.5 meters per second. Is this a coincidence that the same mediums have the same speed? I think not. Last in this screencast, I want to take a look at the relationship that frequency and wavelength share and how it affects speed. By looking at the table of numbers from the previous slide, we can see that the speed of equal mediums is the same. This is because speed is only dependent on the properties of the medium. From the graph above, we can see that when wavelength increases from 0.90 meters to 1.75 meters, the frequency decreases from 3.9 Hz to 2.0 Hz. The same is true in the copper mediums. As a final note, changing the wavelength causes the frequency to change and does not affect the speed. However, if you directly change the speed, then this will affect the wavelength. This screencast shows the wave equation and the relationships we can find by using it.